So more graph stuff. Our last two sections were like frequency distributions, which you can see are very similar to those histograms right in the next section, 2. And the histograms look like a bar graph, but they're different, right? Histograms, they touch and they show the distribution. So a distribution, a frequency table or frequency distribution shows the same thing as a histogram, right? So that's a little review of the last two sections. This section is what are all the other graphs? And truly, people make up different graphs all the time to show what they want. These are just some of them. Histogram is the number one biggest one that I really want you to remember and think through. So let's go through some of the graphs, and then I will open StatCrunch, of course, and show you how to graph some more in there. So you should have seen the histogram, right? But then we can also do some other ones. So dot plot. So this one I've never seen in the real world. I've taught it every year I've taught, but I've never seen it in the real world. So I don't think it's super common, maybe. So a dot plot is where you actually put a dot above every single number, and then one dot represents each data point. So we can see I have 61, 62, 63, or I'm counting that wrong. I have 1, 2, 3, 4, 5, 6, 7. I have 7 on 60. So I could see specifically all my data from a dot plot, and I can list them out. So it still shows frequency, a dot plot, right? Because it's showing how many you have of every specific number. So truly, it's super similar to like a histogram or, but in a frequency table, but those ones group them. This one's specific numbers. So we're not really grouping it. That's kind of the difference. So this one says it shows a distribution and you can recreate the original list. That's it. Those are two things about that graph. The next one is a stem and leaf, sometimes called a stem plot. And with this one, it also shows distribution. It's very similar to a dot plot, but I actually just put the numbers on there. And we really give you your data set in a stem and leaf sometimes. So you still retain your original data, and it's easy to see them in order. So that's kind of nice. So what we do is we have a stem. So the stems on this one is 40s, 50s, 60s, 70s, 80s, 90s, and the 100s. If you had 10, 11, 12, 13, it would be like the 110s, the 120s, 130s. So you can put together the 4 and this 0 to make 40. That's the very first number of this data set, 40. The next number would be 4, 2. So 42. Okay, so I wrote out a couple of them just so you could see that. So the stems are the 10s and the 1s are the leaves. So I can see this distribution is totally a bell shape, right? It starts lower, it's symmetric, starts lower, gets higher, and goes back down. So definitely normally distributed data here. Okay, so stem and leaf you've probably seen before, pretty easy to make. Okay, time series. Great graphs for if you want to show something that changes over time. So maybe you want to show the value of your house from the time it was built. So like my house, this is about my house. It was built in 1981. So like, you could see the value of your house at every single year. And, if it's gone down or up. So it's based on time and it shows trends. So, really, this one happens to be law enforcement fatalities. So it kind of goes up and down on how many law enforcement agents are lose their lives, which is kind of sad data. Okay, so that one you would need time, and you would need to show something changing over time. That's a very specific graph. Okay, bar graph. I now know how I got the pink on the fishing, but when I first made this, I didn't know I could click it and it would not be pink anymore. Anyway, so fishing should be blue. So when we look at a bar graph, we have talked about the different kind of data And so this should be blue. This is driving me nuts. Oh, it came through black, whatever. You don't care. I guess my blue didn't come through and I clicked on it. Okay, so with this one, there we go. Why am I so picky? With this one, every single graph, every single bar has its own thing. So we cannot mix these up with a histogram. Look, fishing has its own little bar that goes up, right? And so does inboard, so does jet ski, so does motorboat, so does sailboat. Everything has its own. So what type of data is best for a bar graph? Our best is categorical data. Really, it is best for categorical data. Should you use a bar graph when you collect numbers? Nope, you probably shouldn't. Now, there are situations where, you can, but it's not usually. I'm telling you, for our class, it's never. It is categorical data that you use this for. And it makes sense. How many people have brown hair? You have a little box for it. How many people have blonde hair? How many people have black hair, right? And red hair. So there we go. How many people have dyed hair, right? Different colors. Okay, so that's a bar graph. Totally can do a bar graph on StatCrunch. It's pretty easy. The other ones are on there, I think, as well, too. So Pareto chart is just where you do the bars in order. Fishing is still pink. Okay, it's no longer pink. I'll have to show you that maybe if I can get it to do it in StatCrunch, but this is the same thing. It's a bar graph, but I wanted to start with the highest to lowest so I could emphasize the difference between them instead of it kind of going up and down. So same thing. Next one, we see this all the time. And this one is used so wrong. So on your labs and on your projects, you better only use this for categorical data as well. You don't want numbers. If every single number in your 100 data set is different, then every little pie piece will be different. Sometimes StatCrunch will like group them for you, but it has no meaning. It's not what we want. So this is another one that we use categorical data for. Okay, bar graph, pie chart, categorical data. So look at this one, we saw the same data. This showed exact number of people, and so then we can add those all up and see what percent the 250 was for fishing. And that happens to be like the 9.19%, right? So each group is a percent. I like the pie charts. They have such good places for these. So we can show most people have a jet ski. Okay, that's what this shows. Super easy. Next one would be motorboat. Super easy to see. This is a good one for like how you spend your day, right? To show someone how much studying you do. Well, green would probably be, sleeping. So you do sleep a lot of your day. And then the rest of the categories of what you do with your day. So that one's a good one. You could do a pie chart on, and any categorical data. Okay. Frequency polygon, it just shows all you do with a frequency polygon really is you connect the dots. And so it's like, where are you at 49.5, you're here. At 99.5, you're up at 10. What is this supposed to be for? This was McDonald's lunchtime. So we've actually seen this data in the first section of chapter 2 as well. But it has a dot on each one, and then you just connect the dots. It's showing frequency, but when you connect them, it's now called a frequency polygon. Okay, the last one, you only have one question on this. It's not something I'm going to emphasize, but I actually find it like super helpful and important, and I might be the only one. No, I'm not. Okay, so QQ plots are a quantile plot. They'll help you identify if a data set is normally distributed. Okay, so I look at this data set. It looks fairly normal. How can I check if it really is normal? Or how can I have a better way than like, oh, it looks kind of bell-shaped, right? We can do a QQ plot, and that should form a line. If it forms a line, then your data is normally distributed. So notice this data is not perfect, but it's fairly bell-shaped. I bet you it would even look more bell-shaped if I did less boxes and And so I did a larger width. Okay, so the next QQ is a right skewed. So look, our tail is going to the right. So we start high and end low, but we keep kind of going like a little trail of a lot of lowers, right? I think of height of women, right? We have some of us that are really tall, and then we kind of trail off at the short ones, or it might go the other way. But look what happens on the QQ plot. It totally curves. It's not line at all. So there you go. Same with left skewed. So see the tail is on the left. So you start low with some trickling and then you go high. That is definitely a curved QQ plot. Okay, so let's talk a little bit about graphs that deceive, and then we'll open StatCrunch and I will show you some cool graphs and kind of go through all the graphs we can do on StatCrunch, Excel as well. Maybe I'll bounce that open as well. So graphs that deceive. All right, we all have been talking about this in stats, especially chapter 1. It's really easy to kind of make stats go in the way you want it to, right? By the way you word your questions and your data on your surveys, to taking out data that you don't agree with, right? There's lots of things we can do to make our data look the way we want. We can also deceive with graphs. So look at these two graphs. Do they show different actual information? They don't. They're actually showing the exact same. Look, Oxycontin is up here at a little above 22, same here. And then the placebo is at about 10. Placebo is about 10, a little above 10, but they show the same information. What did they do to make it look like the difference was a lot smaller or a lot bigger? Is they changed the scale on the side. So sometimes they'll like even skip numbers and not count by the right number. So you have to really look at the scale. When I test you on a project or anything, a lot of times you use technology, so it's a little easier, but you have to count specifically by something or I will mark you down. You have to label every single graph or I mark you down, because that is huge. If you're not labeling things, that's a misleading graph. So that's how most people mislead, is by a different axis information and kind of scaling it the way they different. So we really probably should start with 0 and then go up. But either way, there you go. Here's another one. A lot of times when people use pictographs, they can make an object look bigger. Like this one says, in 1970, 37% of the US adults smoked. In 2013, only 18% of the adults smoked. So the difference between 37 and 18, is that depicted there? Is it really shown there? That looks like more than double. And I guess 18, that it's close to double, but that looks like way more than double. So just be aware of how I could use pictures to make you kind of go with something that maybe isn't the best idea. I thought I had one more with a little house on it, but I guess I don't. Misleading graphs. Let me double check. I don't have any others, but I don't think I do. So the bigger, oh, here's one. All right, so let me go ahead and stop here because then I'll just open StatCrunch as well. And I'm going to share my screen and we will bounce this over. And you are sharing your screen. Perfect. It doesn't have the little green. I think you see what I see. Hang on, I'm going to make sure. Yeah, okay. Just making sure it was on screen 1. All right, so check this one out. So this one shows like that big house just looks like so much bigger, so many big. So this is trying to say the average square foot of a house. So it's like in 1981, the average was 1740, 1990. Oh, it looks so much bigger, but is 1740 in square feet very much different than 2080? No, it's like a big mud room. It's not that different. So a couple hundred square foot is not that much. I mean, if you have a really little house, it might seem like it, but it's really not. And then definitely doesn't look like double. And then they are showing, oh, and look now in 2010, even bigger house, but it's really only 400 more. And this looks like huge compared to this one or this one. So there's another misleading graph by a pictograph kind of thing. Here's another one. If Bush tax cuts expire, it's like now and then, and what's the difference between 35 and 39.6? I know it's a little blurry because I got off the web, but not very much, right? I think if I did the slideshow, you could see it better, but yeah. And then this one was people receiving federal welfare. Oh my gosh, doesn't it look like it is just rose so much, but look at the actual numbers. It isn't rising that much. So they did not start at zero. They aren't counting very well. So definitely sneaky there. Oh my gosh, this one's funny. Itch relief. Again, it's blurry because I stole it off the web, but it's like 1 minute versus 60 seconds. And that's the same thing. And it's just kind of a weird graph. It's like, yeah, clinical study. I just don't like anything. It's not very detailed. I don't really know what it's saying. Okay, last one that's kind of weird. All right, so this one is tuition, room and board, and bachelor's degree earnings. So four-year degree for one, okay, we start at 64 and then we go to 70, like, and then 80, 90, 2000, 2010. That's kind of a weird like gap right here as well. And they don't even talk about the fact that like the money people make is going up as well. Yeah, I don't know. There were a lot of things that I didn't like about where this information came from, which you don't see, but 35, 45, 55, 65, 75, this goes up pretty good. This doesn't here. Can't remember what else it said on there. Diminishing returns on your four-year degrees. I don't know. I guess last time I taught this live, we were talking about, well, what degree did people get? Do we have more degrees in things that don't get you a job? Oh, yes, we do. So you should look at your degree right now. Is it going to get you a job and get you more money? It should. That's the point of college. All right, so those are a little more misleading stuff. So when you open StatCrunch, you can open it on a tablet or whatever you want. You can also open it just from the website or from My Math Lab. So there's lots of places. You got the subscription with your My Math Lab. So let's put in some data. I'm just going to enter some data. I'll just pretend like these are grades. We better get a little bit higher that these are grades. Let's give someone 100. Oh, we didn't give any 70, 70, 75. Okay, put in a little bit of data, and then let's go to the graphs. This is numbers. Let's do some words as well. Let's do like red, brown, blonde, red, blonde, brown, and can I copy brown? I don't think I can cut and copy real easy in here, but most people have brown hair, so we're going to do a bunch of brown, and then black might be another one that we should really do. Black might actually be the most common hair color. I don't know. I can't type today. All right, black. See, maybe we should do another blonde. I don't know. I don't really care. I think you care either. We'll just leave it at that. Who cares? We're good enough. So we have some category data and we have some numerical data, the qualitative and quantitative, right? Qualitative is like categories. Quantitative is our numbers. So we're going to go to graph, and what should I use for my bar graph? Category data, or should I use numerical data? I should use categories, the words, qualitative. Yeah, qualitative. Okay, so with data, and we're going to do set 2, and then we can just say compute. And there we go. And so this graph, this bar graph looks great for our words, our category data. Okay, so there's the first graph. So pie graph, what should I use? Numbers or words? Category again. So we have our data, and it's in set 2 for what we want, and compute, and there we go. And those both look fabulous. If I made a graph, a pie chart with the wrong kind of data, it should look like this. Not good. And what is 30 and 20? Why are those even on there? It's just weird. So we don't like those. That's not what we can do. Okay. Very pretty with words, not so pretty with numbers, especially if every number is different. They're all unique numbers, then it's even worse. Okay, so those are our bar and pie. So when you do your first lab, you should be using those with your category data. What is a chart column? I don't know. Let's see what the chart is. I don't even know what the chart is. Oh, a chart. Yeah, I don't like a chart. So that was the chart. Group stats. Yeah, I don't know. That's newer. I don't even know what it does. Okay, so histogram we learned in the last one. So we would never do a histogram of category data. It only is one variable. It doesn't even let you pick the other one because it says, no, you can't do that. So here is a histogram. Again, we're looking for a bell shape. Is it normal? No, it's not normal. Shows lots of Fs and then like 2 different groups almost. Okay, so that's our histogram. That's from the last section. And then the stem and leaf, we'd have to do of numbers because you can't do a stem of red, blue, or brown and colors and stuff. So compute, here it'll make our stem and leaf for us. So the 20s, the 30s, the 40s, the 50s, the 60s. See, even StatCrunch doesn't leave out anything. If it has a 0 amount, it keeps that gap for you because the gap shows something. It shows that your teacher was just randomly typing in numbers and then decided to make them look like grades. Okay, so that is the stem and leaf. Box plot. So box plot again is of numbers. I think we learn about a box plot in a different section, but it's here. So box and whisker plot looks like this, and it actually breaks your data into 4 pieces, 1, 2, 3, 4, and it shows this has the even amount of data in each section, and it shows how spread out your data is in each section. And so we'll learn that later in the next chapter. Or maybe the next section, I don't remember. Violin plot, I don't even know. What is a violin plot? Let's look. Sorry, I shouldn't laugh. I have absolutely no idea what this is for. I don't know. There you go. Have you ever asked for a violin plot? Dot plot. Oh, here's a good one. Dot plot. Again, dot plots are of numbers. Perfect. It does do dot plots. I didn't think it did. Perfect. There's our dot plot. Don't even have to count them and put them on there. And I don't have very many repeating numbers, just in the 30s and 70, no, 85. 85 had 2. Yeah. Okay, and then that was the dot plot. Mean plot. I don't know what that is either. What's a mean plot? Oops. Forgot to click my one variable, and that's just representing this one here. Yeah, I guess it just shows the mean plot. I have no idea. Weird. Okay, we're never using this. Scatter plot. We don't have the data for scatter plot. We'll do it though in the end of the class, and again in I think it's 3-4 actually. We do box and whisker and scatter coming up. So scatter plot, I can't even show you. It's dots where you link 2 things like height and weight. Each height and weight of each person is 1 dot, and it like goes over height, up weight. It's got a bunch of dots. You've probably seen it before. Bubble plot. What the heck's a bubble plot? Can't do that one either because we don't have X and Y's. Multiplot, don't have any clue. All of these, I have no idea what these are exactly for, but we do know QQ plot. So let's notice it's only of numbers. What are we looking for when we do a QQ plot? Straight line. That's going to show normal. Not a real good straight line. It's like curves down and then back around. And we knew that because our data is grouped and grouped below and above. And you could kind of see that. Not a real good normal distribution here. Cool. So the QQ plot, you don't have to even understand how they make it or anything because that one's weird. It's a quartile plot, but you can just plug it in here for that and see if it forms a straight line. It's a great way to check for normal distribution. All right, that's all I got for this section. Bye, guys.